this topic is so huge, very broad actually, and it is most commonly used in economics. You can use it in economics, you can use it in statistics, but most of the tasks that I personally have dealt with, I have dealt with tasks on economics. On economics. So, what do we mean by panel data analytics? What do we mean by panel data analytics? I want you to understand this concept. If you haven't encountered the one panel, at least you can have a clue what is it before we start the analysis part using the STATA. So, panel data analysis, which is also known as longitudinal data analysis or cross-sectional time series analysis, is a statistical method used to analyze data that is collected over time on the same subject or entities, right? So, in panel data analysis, observations are made on multiple individuals or organizations or other units repeatedly over a specified period of time. And a good example of this one is the data that I've given you. You will notice that we are trying to capture specific variables on different shops or supermarkets, the way you want to say. So, this type of data provides insight into both the cross-sectional and time series dimension of the data. So, it will allow for comprehensive analysis of the relationship between those variables that you are going to analyze. So, panel data analysis is commonly used in various fields such as economics, finance, sociology, political science, and many others. So, it offers several advantages of other types of data analysis methods by incorporating both individual specific and time specific effects. The panel data analysis will allow the researcher to control for both an observed heterogeneity, capture the dynamics of the data, and improve the precision of estimates. There are four different types of panel data models. We have, by the way, they are not even four; there are many. They include the most commonly used are the fixed effect model, the FE, and the random effect model. The random effect model utaonyesha zingine inside the software. So, fixed effect model. What do we mean by fixed effect model in panel data analysis? A model with fixed effect will account for individual specific effects by including individual specific number variables in the regression model. So random effect model, on the other hand, it will assume that individual specific effects are uncorrelated with the explanatory variables. So panel data analysis will enable the researcher to examine various research questions such as the impact of policy changes to determine the determinant of economic growth and the effect of let's say education on earnings, or any model that you want to come up with. And the method that we commonly used in panel data analysis is just regression model. But now, the variables that we will be using in panel regression model, the data is a combination, or the data is contributed from different individuals. So the data is a combination of different individuals, but capturing the same words, capturing the same content that the researcher wants to analyze, I think now I want us we have a look on the data sets that I shared with you. So the data set that I shared with you. We have the company, we have the identify, we have year. These terms, these are economical terms. This is PC, price consumer index, something of kind. This is TDC, total. Kitu kama hiyo. Kuna hii nayo nakumbuka ilikuwa the return on assets. So ni vitu kama hizo. But sasa we have company. We have company. Our first company is Igadas Limited. We have 5 variables. We have 5 variables from this specific company. We have the Kakuz PLC. We have them here. We have Capturuati Co-Factory or Limited, something of kind. We have those data here. Now, what we mean by panel data analysis now is that when you want to run a regression model on a PC, for example, as your dependent variable, and TDZ and EBC and ROA as your independent variable. One is dependent, other is independent. We are trying to come up with a regression model that captures the information of companies. Are we together? That captures the information of these companies. And from that cross-section of data, we can come up with analysis on comparison of different companies. For example, here you can compare this company together with this one, So, yeah, that is, you can compare companies. You can compare the overall companies, or you can compare between the entries in a specific company. So the difference between a normal regression analysis and panel data analysis is that on a simple regression analysis we just rely on variables, but in panel now we come up with cross-sectional data that will be captured in our analysis. That is, we have this data here. So and you can tell that, for example, on a company alone, we have how many? We have like these are companies. These are companies up to there. So we have so many companies here. I think they have around 49 something of kind. We have some 49 companies, and for you to save your data, in the process of preparing your data for panel data analysis, you must have an identity ID, or a unique identifier that will tell the STATA memory or any compiler memory that this value should be treated different from this other value. That's why we have one here, and identify we have one. Then we have two here, because Egan's Limited is different from Kakuz. So Kakuz takes part 2, take number 2 up to this point. We have Capturati Core Limited, takes number 3 up to this point, and we have the Lemurti takes up to this point, and we have time variations from both. This data was taken was recorded between 2017 and the year 2021. That's why we have from 1 up to 1 we have 2017 up to 2021, and the second one starts from 2017 up to 2021. The third one's 2017 up to 2021 mpaka huku mwisho, so up to the end. Okay, have you now understood the difference between simple linear regression and panel data analysis? Have you understood the difference between the two? Priscilla? Priscilla, are we together?
Hey, yes, we're together.
Okay, I think umelewa the difference now between a simple regression together with a regression from panel. So.
Yes.
Okay. Frida?
We are together.
We are together, very good. I think now we can continue. Now, the reason why we use identify as names, you remember I told you last time, the time that we were doing introduction, that the STATA memory does not recognize or does not do calculations based on the text, based on text like these ones here. STATA does not understand what an Huygens limited is, but if you assign one a numerical value, the STATA memory or any other compiler will be able to understand this one means this one, this two means this one. That's the reason why we use the identify to come up or to replace these parts, the parts on the company. So. Now, let us go into our STATA. Let's go into our STATA. You just clear your memory first before you import. So just type clear and everything goes right. From that now, you can import that particular data set. You just click on file, click on import, then Excel spreadsheet. From there you can browse the location where your data is. So my data is called panel data. You just click on open and import your first row as variable names. So import first row as variable names, then you just click OK. Then we are done. Kila mtu amefanya hivyo before we continue? Yes? I want to hear from you. Friend who may import. Joy? Nataka kusikia kama mmeimport ili nijue tuko pamoja. I want to hear.
Yes.
The other one? Nataka kusikia sauti ya watu watatu so that we can continue. Okay, let's continue now. We have the data set here with us. When you click this part here, you will be able to see all the data. See there, utaona hiyo data yote, Kenya Power, what center. So this is the data that we have. Now, the process is very simple. We want to declare this data to be in panel mode. We want to declare the data to be in panel mode. So we have the data. The data is present in our memory, so we want to declare it to be in panel or to be in longitudinal format. So okay, what you do, you can use a command or GUI, but I prefer use GUI because you will not forget easily, but you can easily forget what the command. Click on statistics. So click on statistics and browse up to this point here. So this one here, the longitudinal / panel data. Tuko pamoja mpaka hapo. From that now you can click on setup and utilities. You can click on setup and utilities, then click on declare data to be panel. Declare data to be panel data. You click on that point. Okay, we have a dialog box here. Where you have to insert the specific identifier, the specific panel data identifier. We have the panel ID variable. You click on this down arrow here. So click on this one, and I want to hear from you. Which value can we use as panel data variable according to this data? Which one? Nataka kusikia kutoka kwenu. Which one can we use? Yes? Nataka kusikia kutoka kwenu. Which is the unique identifier for the companies? Is it the company or the identify these values? Is it the company name or these values here?
I think the values. The 1 and 2.
The 1 and 2 and 3. Not only 1 and 2. We have 1, 2, 3, 4, 5 up to the last one. So we have how many? We have around we have up to 49. So the identify column will serve as a special identifier for our data. For our data. So what do? We select the panel ID variable as the identifier. Click on identify variable. So we have this other part here for time variable. You can either specify the specific time when the data was collected, or if you don't have, you can go with that. But for our case, we have time, we have the time when the variables were recorded. So you mark this box here, you mark time variable box, and you select what? You select, what are we selecting here? What are we selecting? Can I select again?
The year.
The year. So yeah. So we select here. And you will remember the time units, the display format for the time variable was in this format. So use format of time variable. So we want to change it to yearly, because actually our time variable is recorded on yearly basis. So you click on yearly and click OK. Let's see what is happening. What output are you getting from your machine? We have panel variable identify, which is strongly balanced. Okay. The reason why it's strongly balanced is because our data is clean. First of all, our data is clean. And check here. We have ones and 5. So every number here appears 5 times. Every number appears 5 times the way the company name appears 5 times. Are we together? That's why our panel variable is strongly balanced. That's why our panel variable is strongly balanced. We have time variable, we have the time variable, and our time variable is on yearly basis, which starts from 2017 to 2021. It starts from 2017 to 2021. Delta, the data is on in 1 year. In 1 year. Suppose the data was recorded in an interval of 2 years. How would we change this 1 year? Ungekuja hapa kwa statistics. Okay. Ungekuja hapa kwa statistics, set up utilities. Okay. Ukikuwa hapo, you see this delta here. You can change this delta to any interval that you want. So then make sure you change the same in your original data set. You change the same variable, that is year variable, in that original data set. Okay, now what we have is year is data having been declared to be in time, to be in panel data analytics. So let's continue. The other thing is for describing the summary statistics. Summary statistics for what? For data, for your panel data. You just click on statistics. And before we continue, remember the command that is responsible for this one is just this. So just this one. So xt sets, you start with the identify, year, and yearly. So are we together? So this is the same command that is used to create this data in that format. Okay, let's continue. To get summary statistics or descriptives for your panel, you just click on statistics, longitudinal panel data, setup utilities, and click on summarize XT data, and from that one you can either leave empty if you want to display all. Sawa. Okay, I think you can see. So the command that's responsible for displaying the descriptive or the summary statistics for your data is xtsum. Sawa. xtsum inakupea all that. And I want us to look on this output here and see what is happening. Okay, number one, for the company we don't have any values here. Who can tell us the reason why we don't have values for company? Nataka kusikia kutoka kwenu. Who can tell us why we don't have yes?
Is it because STATA does not read like statements as opposed to numbers?
Okay, yeah, very true, very true. The data, we cannot have summary statistics for data in string format. So we can't. But for overall, we have it. So there, we have for the overall. And what you need to understand here is these are the variables overall, between and within. Tunakuja hapo kwa hiyo description. I want you to check on this part here. Okay, what is N, capital N, in statistics? No, apart from this software. In statistics, when you see something capital N is equal to 10 and small n is equals to 5, what do we mean? Yes? Okay. Capital N in statistics. Yes?
The total number of observations.
Okay. Capital N is the total number of observations or the total population. So, what of small n? What of small n?
The sample size.
Sample size. Very true. So the small n is used in statistics to refer to a sample size. What is T according to this output? What is T? Capital T and observations. Yes? What is capital T? Okay, capital T is used to refer to time interval, yeah? Time interval. Because we have our time, let's see, our identify variables appears how many times? It appears 5 times per sample. So that is why we have this T. So I want us to interpret what do we mean by the overall, by between, and by within. So I want to interpret that one from what I documented here. Okay, I want us, so this output is the same as this one here, but I tune these three parts here. So it was from PC, TDC, EBC, and ROA. And let's try to explain that output before we do the other analysis. So for each variable, PC, TDC, EBC, and ROA, the output provides the following information. What do we mean by the overall? And overall for this case is the values that correspond to this row up overall mpaka mwisho. So yeah, those are the overall value. So this value, this row displays the overall summary statistics for the variable across, I want you to get the name, across all observations in the data set. So it includes the mean, standard deviation, blah blah blah, and all that. What do we mean by the between? The values on between row. This row will present summary statistics for the between group variations. Are we together? For between group variations. For example, between PC, between TDC, between EBC. Those are between group variations. So yeah. Within this one here, yes, yeah, that the within, it provides the summary statistics for the within group variation of the variable. So yeah. So just given the observations, we have gone through the observations. Now let's do panel regression model. What is panel regression model? Panel regression model is a statistical method that is used to analyze data that includes both the cross-sectional and time series dimensions. And a good example is our data. So it allows for the examination of relationship between variables while controlling for individual specific and time specific effects by incorporating both within group and between group variations. So panel data regression will enable the estimation of fixed or random effect model that captures the individual heterogeneity and time varying factors. So this approach will provide more robust and efficient estimate as it utilizes the additional information provided by the panel structure of the data. So the panel data regression is particularly useful in studying dynamic relationship, exploring case causal effects, and addressing issue of heterogeneity, making it powerful tool in social sciences, economics, and other fields where data has both cross-sectional and temporal dimension. And a good example is the data that we are using. We have the dimensions and the cross-sectional information of those particular variable entries. So okay, let's do a regression model with random effects and another one with fixed effect. So you should be able to differentiate with the appropriate or to research on the appropriate model to use in your analysis. Remember they vary. I can decide to use fixed effects and then come out with the wrong estimates. All. So it's upon you now to research on when is appropriate to use fixed effect model in your panel analytics, or the other one is the random effects model. So yes. So I want, as we do a linear regression model, and the process is very simple. You click on statistics here. You click on statistics. You go to your data, that is longitudinal panel data, and click on linear models. Click on linear regression, the FEREPABE. So these are the 4, but kuna ingine hapa inawekwa hapa, hizi zinakuwa more than 4, so zinakuwa 5. Okay, suppose we want to do a regression model on the principle, the PC. I don't remember the specific full names for these abbreviations, but you understand what we mean. When we have a dependent variable as PC, for example, you click on PC as your independent variable, and TDC as your independent variable. Remember, these are regression models, so you can insert even more than one, right? You can insert even more than one, but sasa nataka tukue na the only two, the only one. Let's see, we want, as we have only the TDC, so click on that, input TDC, and I want you to be very keen here. We have model type. This is generalized least square method. These are random effect, and the RE, and the other one is the fixed effect. I want, as we regress using the fixed effect, and the other one using GLS random effect. So after that, you just click on OK. You just click on OK, and you have your output. And you have your output there. So just a minute. Munaelewa venye tunafanya? I want to hear from you. Munaelewa venye tunafanya kweli? Yes? Are we together? Yes, Frida, munanipata? Joy?
Yes.
Munanipata, sindio? So,
Yes.
this is the output for fixed effect. I want you to be keen on this part here. This is the command that is responsible for performing a regression model with fixed effect. We have an output here, and we have the number of observations. We have 249. Remember, the number of groups were 49 times 5. Kila group ilikuwa inaapia 5 times, so we have 245. So we have the R squared within and between the overall. We have them here. So the observations per group, minimum they were 5, average they were 5, blah blah blah, they were 5. So what is the p-value? The p-value is 0. These are the F statistics of 40.43. Unakuja hapa, this is the sigmas for the fixed effects output. These are the coefficients for the model. So it means this model had significance. The TDC variable ilikuwa na significance effect on the PC because of this p-value here. The p-value is 0. Now, I want us to interpret this one here. I want us to interpret, I think this is the one that we have just performed here. PC, TDC are here, random effect. So this is for FE, this is for fixed. I want us to repeat the same for the random effect and see what is the answer. Random effect, this one here, mark that one, hit and mark automatically, then click on OK. So we realize that there are some differences. For example, OCO P values, blah blah blah. OCO, we have the P values. Remember the importance of the main aim for running a regression model is to use the P values to either tell whether one variable has significant effect on the other or not. And let's interpret this output that you can see here. So this is an output from random effect generalized least square, the GLS regression using the panel data, and here is the interpretation. So the regression model examines the relationship between dependent variable PC and the independent variable TDC. The coefficient for TDC is estimated to be negative with a standard error of this one. However, this coefficient is not statistically significant because what? Because you can see the p-value on TDC is greater than 0.05. So is not statistically significant as the conventional 5% level. The p-value is 0.789, so indicating that the relationship between TDC and PC is not statistically different from 0. So the constant term is estimated to be this one with a standard error of these are this part here. Just a minute. These are the constant, but this is in a manner, so we can do away with them. At least, I want us to go to this part here. So, the within group R squared, the within R squared within is 0.77. This part here, where is it? This part here. I want you when I talk of R within, R between, R overall, we will be relying our emphasis on this part alone. So the within group R squared is this part, indicating that approximately 17.17 of the variation in PC can be explained by time varying factor within each panel. I want you to get the within each panel. So the between R group, the between R squared is 0.7373, suggesting that around 73.73% of the variation in PC can be attributed to difference between panels and the overall R squared. And the overall R squared is this one, representing the proportion of the total variation PC explained by data model. So the estimated random effect model assumes no correlation between the individual specific effect. Remember, before you run a regression model, number one, you must have tested the assumptions that comes with the regression model. Yeah, we say that the data should not be correlated with each other, or the correlation between different groups should not be experienced. So the estimated random effect model assumes no correlation between the individual specific and effect that you have, that is, and the independent variable TDC. These are the parts that we are talking about. Where are they? These parts here, the sigma. So yeah, we are talking about the sigma. Let me see. Channelizer. The most important thing was on this part. We interpret the R squared, the efficiency. Remember, R squared is used to tell whether the model is effective or not, together with the p values. The output also provides estimate of the variance components. The estimated variation of individual specific sigma u is this part here, and the estimated variance of the idiosyncratic error sigma, this one is this one here. So the estimated value of the role remember the role in regression analysis, how we use the role. You remember that one? This is the interpretation. It indicates that when you multiply this by 100, this becomes 92.32% of the total variation of the dependent variable is due to individual specific effect. That's the mean y. So in summary, the output suggests that the independent variable TDC is not statistically significant in explaining the variation in the dependent variable. Is not statistically what? Significant. Why? Because we have a p-value in that model which is greater than 0.05. So we just say it's not statistically significant. So the model overall fit is not statistically significant. Why is the overall model fit not statistically significant, if I may ask? Which value do we use to give that conclusion in regression model? We use the probability that the overall p, yeah, the overall p, you can see the overall p is greater than the significance level, So the model overall is not statistically significant, and the majority of variation in PC is attributed to differences between panels rather than within. The other part is on the stationarity test in panel data analysis. Remember, we have so many methods. We have the 11 lane 2, we have zinakwanga mingi, there are so many, especially in this software. And what's the importance of testing for stationarity in data in panel data analysis? Remember, we have said that panel data analysis, it will have some parts of time series, and for you to give conclusions or estimate on time series analysis, your data should be stationary. You remember, I think we covered that last week, where we were running what? We were running some ADF tests and the augmented decay filler test to tell whether the series is stationary or not. So we can use the inbuilt test, and for you to do that, you just click on statistics. So just click on statistics. Okay, before we continue, nani are we together up to that point? Okay, nisikuwe naongea mimi mwenyewe. I'm sure mnaelewa kitu, si ndio? Right? Joy? Joy and Frida.
Yes.
Mko sawa mpaka hapo tumefika, si ndio?
Yes.
Okay. Let's now perform those other tests. Let's see. Okay. You just click on statistics. Click on longitudinal panel data. Then click on the unit root test. Click on unit root test. Click OK. And this window will pop out here. We have so many tests that are used to test for the unit root in different time series, in different variables or in time series. When you click this drop down menu here, you will see that we have 11 lane 2, we have Zavels, we have bread track, we have in-person shin, we have Fisher type, and we have this other one here, and LM stationarity. I want you to click on the first one, that's the 11 lane 2 methods, and you just click on the variable that you want to test whether it's stationary or not. For example, you can start for example, let's click on TDC, and I want you to mark that include. I want you to mark this box for including the time trends in your estimate. So click on that part, include time trends, and you are done. You just click on OK. So you just click on OK, and after clicking OK, you have the output. You have the output. What do we have on that particular output? This is 11 lane 2 unit root test for TDC, and the null hypothesis is that the panels contain unit roots, and the alternative hypothesis is that panels are stationary. We have number of panels here, they are 49. Number of periods, we have 5 periods. Asymptotics, that is 0. AR parameter, I want us we concentrate on this part here. This is ADF regression 1 lakh, LR variance, but it's kernel 5 lakh average chosen by. So the Levin lane 2 will choose or will select the best lags that fit in your but let's kernel explanation of this model of Levin lane 2. So of Levin lane 2. This is an adjustment statistics, and this is the other adjustment statistics. So we have the statistics together with the p-value. So we use the p-value to make conclusion on whether the panel is stationary or not, whether the data is stationary or not. So how do we interpret that one? The output is from the leveling lane 2 unit root test conducted on the variable TDC in panel data using STATA. So here's the interpretation of that particular output. So the null hypothesis of the leveling lane 2 test is that the panel contains unit roots, indicating that the data is not stationary, or indicating non-stationarity. So the alternative hypothesis, the HA, is that the panel is stationary, implying the absence of the unit roots. So the test is conducted on a data set that is with 49 panels across sectional units, and 5 time periods, as you can see from this part here. And the leveling lane 2 test assumes a common AR. It will assume the common autoregressive parameter and includes panel mean and a time trend in the analysis. So the output provides 2 test statistics for the leveling lane 2 test, the unadjusted T test, T statistics, and the adjusted T statistics. For the unadjusted T statistics, the value is negative 0.39, and it does not have a corresponding p-value. So for the adjusted T statistics, the value is 1.3 e plus 15, and the p-value is 1. So the adjusted T statistics is accounting for Bartlett-Kennel variance, as we have seen. And in this case, based on the leveling lane 2 test unit, we will not be able to reject the null hypothesis because our p-value is greater than significance of 5%. So yeah. So okay. So we cannot reject the null hypothesis of the presence of unit root test, of the presence of unit roots or non-stationarity in the variable TDC. So the unadjusted T statistics and the adjusted T statistics do not actually provide the enough evidence against the null hypothesis, as their magnitude are not significant, and the p-value for the unadjusted T statistics is equal to 1. So as we have said. So therefore, the test statistics that the variable TDC in the panel may exhibit non-stationarity indicate that a further analysis or differentiating technique may be required to address that particular issue. We have so many diagnostic tests that comes with our panel data analytics. So I documented just one, that is the Haussmann test. So you will just go and look for others. What does an Haussmann test do? What does Haussmann test do? So the Haussmann test will compare the efficiency, which one or which model is more efficient between the fixed effect and the random effect model. So it tests the null hypothesis that the random effect assumption is correct against the alternative hypothesis that the fixed effect assumption is more appropriate. Is more appropriate. And the first step is to run a regression between two variables with fixed effects and store it. And the second part is you run a regression model with a random effect and store it. Then from that part you can run the Hausman tests. So. And let's see. So you run this part here for FE. You come to the longitudinal panel data, linear regression, then this part here. Let's run the first one for FE, for example. FE, that is the fixed effects. Click OK. Yes, this is the output. So estimate, just write estimate, store. This is for FE. Estimate is store FE. So we have stored that estimate. After ukifungua hapa you will see it. Let's see. For the fixed estimate for the fixed effect model, we have it there. So. And let's try for the random one. Click on statistics. Longitudinal. Now, instead of fixed effect, you can click on a GLS, random effect model, and click OK. Click OK. We have it there. Then you can save. Estimate, just write the command estimate store RE. That is the random effect. You just click on that. From there, you can run the Hausman test now. Hausman Ferre. This is the Hausman test. Which one is more efficient between the random effect model and the fixed effect model? So this is the output. We have the TDC. We have the fixed effect coefficient, the coefficient for fixed effect, and the coefficient for what? The coefficient for the random effect. We have the difference between the two. The difference between the two is here. So we have B is consistent and the null hypothesis and alternative hypothesis obtained from the regression model. We have the B. The test is that the null hypothesis is difference in coefficient is not systematic. So if we get evidence to reject the null hypothesis, we will be assuming that the difference between the coefficient of B and the B, these ones, is systematic. So. Now, how do we interpret this particular output here? You can see it here. How do we interpret it? The output is from the Hausman test, as we have shown, as we have actually performed, and we are using it to compare the fixed effects and the random effect model. So the test is performed on the variable TDC. Here is the interpretation of the information. The null hypothesis H0 of the Hausman test is that there is no systematic difference in the coefficients between the FE and RE model. The alternative hypothesis HA is that there is a systematic difference. So the coefficient estimates for TDC in the FE model and RE model are this one and the other one you can see. So the difference between the fixed effect and random effect for TDC is this value here, the negative 3.018956. So the standard error for the difference is not actually given. So the test is statistics for the Hausman test is the chi-square of -1 to 6. As you can see, we have it here on this part, the chi-square value here, the chi-square value there, and the negative value of test suggests that the model fitted on this data fails to meet the asymptotic assumption of the Hausmann test. This indicates a potential issue with the test and suggests that there is a need for generalized tests such as switched commands in STATA to obtain a reliable result. So that is just one part of the diagnostic test that is performed in this panel data analytics. So it's upon you now to go and research more on some diagnostic tests that is performed in STATA and how to perform them. So kila kitu iko hapo is just a matter of clicking and getting them. So yeah. Any question up to that point? How was the lesson? How was the lesson?
The lesson was good, but at some point my internet went off, so I may have to review on the videos that you sent.
Oh, no problem.
For the last bit of the class. I was floating for the last section.
Oh, probably. Frida, your suggestions? How was the class? I think umekamata A, B, C, D, sindio?